My name is Chanujayatissa, and today I will be presenting my honors contract for COSC 311, which is the Algorithms and Data Structures class. So, for this honors contract, I researched and learned about two additional topics, radix sorting and DQs, which is a double-ended queue. So I learned this sorting algorithm and this data structure DQ, and I am going to be presenting and explaining what this data structure and this sorting algorithm does. And I also made a program using these two data structures and the sorting algorithm. Uh, and I will be showcasing and presenting the program as well in this video. So, to start off, let's first go through what exactly radix sorting is. So, radix sorting is basically a non-comparative sorting algorithm. And compared to every other algorithm that we learned, which were comparative algorithm, this is quite different. And this is a non-comparative sorting algorithm. So because of this reason, it can only be used to sort numbers, right? And in the next slide, I will go over the exact sorting algorithm and how it's done. But for this slide, let's go over the basic implications of radix sorting. Radix sorting. So the time complexity of radix sorting isn't the best, but it's all right. So it's basically O(n)k, big O of nk, where n is the number of elements and k is the largest number of digits for the largest number in the data set. So this is pretty much better than the elementary sorts like bubble sort, insertion sort, and selection sort because its time complexity is a big O n squared, but not as good as the complex sorting algorithms, which are merge sort and merge sort, heap sort, and quick sort. So it's not as good as merge sort, heap sort, and quick sort because they have a time complexity of big O log of n. So therefore, it's not as good as them. But still, this is moderately good compared to all the sorts that we have learned so far. So the applications for radix sorting mainly involve numbers, like sorting deadlines or data with numbers. And it is very efficient for large data sets. That's one of the uh, main good things about radix sorting. So now a quick let's quickly look at how radix sorting is actually implemented. So what the basis of radix sorting is the counting sort algorithm. Looking at this diagram right here, there's four levels for it, but let's start off with the first row right here. So in the first row, as you can see, uh, let's check the time complexity for this first. So it'll be number of elements, which is 1, 2, 6, 7, 8, 8, and the largest number over here is 802. So it'll be where we said nk, and n is 8 and k is 3 because the largest number has 3 digits. So how this algorithm will work is first it will look at the smallest digit, which is the units digit, right? Of each number, it'll look at the units digit over there, right? So then it will use the counting sort algorithm, which sorts a set of numbers in order. So it will only look at the units digit of each number and it will sort the numbers according to that, right? So then where it'll be like the zeros will come first as you can see in the second row, and then the 2, and then 4, 5, and then 6. And after the units are sorted, it'll implement the counting sort algorithm again on the tens digit. And as you can see, some numbers might not have a tens digit, like 2 over here. There's no tens digit, so we consider it as 0, and then it'll sort it from there for, right? Uh, so over here, it'll sort the second digit, the tens digit, over here. And then in third row, if you can see, the second digit it is already sorted, right? 0, 0, and then 2, 4, 6, 7, 7, 9. So it's already perfectly sorted, right? And then lastly, it will do the same thing with the third digit. And as I mentioned before, if there is no digit, it will be considered as 0. And then once finally the third digit is also sorted, the array will be completely sorted, as you can see down here. So that is basically how Radix sorting works. It implements the counting sort algorithm over and over again in order to sort the entire array, in order to sort the entire data set. Right. So that is Radix sorting. Now let's move on to DQs, which are double-ended queues. Right. So we learned quite a bit of data structures in the class, which include stacks, queues, linked lists, binary search trees, just trees, and many more, right? And different types of trees. But this DQ, when compared to queues and stacks, I would say it's better than stacks. And in queues also there's circular queues or just the normal queue. It's better than both queues because it's more efficient due to its features. So now let's go over double-ended queues. So double-ended queues is a linear collection of elements, this data structure, and the key feature of DQs is the fact that you can insert and delete from both ends. Because if you remember in queues, it was mainly you can only insert from one side and you can only delete from the other side, right? That's how it was implemented. But DQ, the specialty is that you can insert and delete from both ends. So this data structure, as we learned in class, can be again implemented as an array or linked list. So this, due to the fact that it can be inserted and deleted from both ends, it's considered as more versatile than queues. And finally, the time complexity for insertion and deletion of DQs is big O of 1. Yeah, so that is basically a summary of all the uh, a summary of all the basic features of a DQ. And now let's look at the data structure itself. So let me move this a bit down right over here. And yeah, as you can see, this is a basic data structure of linear elements. Uh, and you can insert the data at the from the if you consider the front as the left hand and the rear as the back end, as the right side end, as you can see, you can insert and remove both from the front, and from the rear end you can also insert and remove both. So that is the basic DQ data structure, and that pretty much sums up my presentation. But I have the last thing to do, which is show the program that I implemented for the owner's contract. So let me open Eclipse right here and clear this out and make this a big. But before that, let me just show you this. So these are the uh files for my program. This is the task set. Okay, so a basic rundown on what I did for the program is basically implement a task scheduling program where users can enter, create different tasks, and set a priority and set a deadline for the tasks. And then to store the tasks, it'll use DQ, DQ data structure, and to sort the tasks, it'll use Radix sort algorithm. So this is the data structure and algorithms and the entire backend of the program. So as you can see over here, I have four different classes. The main uh, class is the task scheduler class, and then I have a task class for all the tasks, and I have the DQ data structure to store the elements, and I have the Radix sort algorithm in a separate class itself. So now let's try to run the program and let me show you all how exactly the program works. So if I just run it, it'll first print out a menu for the user, right? Where the user can select any one of the options from 1 to 5 to carry out a task. So let's first add a task into the system. So enter task description. You can say complete your homework. And then priority will be 3 and deadline will be, so let's just take it as, since it's, oops, what just happened there? Oh, never mind. I thought I lost the video for a second, but let's get back to it. So since it's December, let's put a date with December and put it as mm, 10 first. Or let's just put it as 20. Might as well put a big number. So due date is in a long time, and that. And then let me add one more task just to showcase how the program works and put a random description which does not matter. And for the deadline, let me put December 1st so that I can show you how the sorting actually works, right? So then after that, you can say, so you can view all tasks, right? So when you view all tasks, it won't be sorted because you have not implemented the sorting yet. Because as you can see, number 4 is the sort tasks by deadline feature. So you press number 4, then it says tasks have been sorted by deadline. And then you can display it again, view all tasks. And as you can see, December 1st is first and it's priority 1. So therefore, it's higher up in the list as well. So pretty much it sorts the data like that. And another one of the features that I implemented is the ability to delete a task. So if let's go ahead and delete a task, and it says enter the index of the task to delete. So the index is 0 because it's numbered over here. So let us delete 0 and then let us view the tasks once again. And as you can see, only one task remains, which is the December 20th deadline task. And those are pretty much all the four features. And finally, you can exit the program and then exiting task scheduler. Goodbye. So that is pretty much my program, and that sums up the entirety of the program and the honors contract too. So pretty much a summary of the entire honors contract is I researched about DQs and Radix sorting and its efficiency, and I think this was a really good experience learning about an additional segment of data structures and sorting algorithms in order to expand my knowledge. And I think this honors contract was really helpful for me to learn more further into depth of the class. So that's all for my honors contract, and thank you so much.